Section 8.5, Voltage Sources. So in the last few chapters we talked about conductors and insulators, particularly in terms of how heat is transferred from one object to another. Conductors are good conductors because they have free electrons. And this is true for things when they conduct electricity as well as heat. So materials that tend to be good conductors of heat are also good conductors of electricity, because the electrons can easily flow in that material, they can move through. The things that are good insulators of heat are generally good insulators of electricity as well. For example, air is not a good conductor of heat, so you can stick your hand inside of the oven and you don't get burnt. It's also not a good conductor of electricity. If it were, the electricity would jump out of the walls. So what happens in these conductors is that the electrons are basically pushed, and they bounce and hit the electron next to them, which pushes and hits the one next to that, and so on down the line. And you don't so much have one electron traveling the entire path of a circuit or some wire in your home. You instead have a signal that travels through as the electrons hit one another. It's just a slight nudge, and that slight nudge gets everything moving. When there are potential differences between 2 points in a conductor, so between 2 points on a wire, then charges will flow from the region of higher electric potential to the region of lower electric potential. That charge will flow until both ends reach the same electric potential, until they've reached equilibrium. In order to maintain that flow of charge, you have to maintain the potential difference. This is what happens when batteries die. As you'll see in the next video, batteries are made up of layers of different chemicals, and those chemicals generate a potential difference within the battery. So when you plug a battery into something, there's a potential difference, and the electrons are pushed along in the wire. When that chemical reaction runs out, the electrons are no longer pushed, and the object stops working. When you're dealing with something that's rechargeable, the chemical reaction is reversible. When you plug it in, the electricity reverses that reaction, and you can then unplug it and reuse that same battery. In order to sustain the motion of the electrons through the conductor, you need a suitable electron pump to maintain something that is a difference in potential. This is something like a battery or a generator. You can think of a battery as something like a fountain, and the water are the electrons. If you think of a fountain or something that you see in a garden or a mall, there's water in the bottom and there's water coming out of the top. And that water is just recycled from the bottom, it's collected, and there's some type of water pump or something that pushes the water to the top of the fountain so that it can come back out the top again. This is exactly how a battery works with electrons. The battery just pushes the electrons from the bottom, and they hit one another and slowly move through the conductor.